Hello everyone and welcome back to FE Exam Prep Solutions. In today's video, we're going to be going over the effective stress at a depth in a soil situation. This is a geotechnical FE exam problem and a pretty typical one that we see on the exam. If you want a framework for solving any FE exam problem, I have the 5 steps to solving any FE exam problem guide in the description down below. It's 100% free. Go ahead and check it out there if you're looking for a framework. Now we're going to dive into the problem. I'm going to show it up on the screen. Go ahead and try and solve it ahead of time, and then I will go in and solve the problem in front of you so you can see what you did wrong or if you got it correct. So let's launch into the problem here. Okay, so we have the FE exam problem. We have effective stress at a depth with a diagram. You may have to draw this diagram yourself on the test, but for visual reference, I wanted to put this here. This is the FE exam excerpt from the reference manual. On the test, I would search for something like effective stress or uplift pressure head if you get a problem like this, and it should show the part on the manual that you need to use. So the question is, a soil profile consists of 2 layers, 4 meters of sand with a unit weight of 18 kilonewtons per meter cubed, and then 4 meters of clay with a unit weight of 20 kilonewtons per meter cubed. The water table is located at the top of the clay layer, 4 meters below the ground surface here. What is the effective vertical stress at the point 4 meters below the water table? Use the unit weight of 9.81 kilonewtons per meter cubed for water. Okay, so let's dive into this problem here. So you can see here, effective stress is going to be normal stress minus the uplift pressure. This is really going to be the key here. There's actually a couple ways you can do this. I think there's a fast, simple way, and then there's a kind of a by the book way. I'll kind of show both of them. But we notice here that the water table is 4 meters beneath the surface. So we have 4 meters of sand that is not going to be affected by uplift pressure. So we're going to go 4 multiplied by 18 newtons per meter cubed. Make sure to keep our units consistent there. And that is going to give us the result of 72. So that's going to be this stress, or this normal stress here in the sand layer. Now, when it comes to this layer that is beneath the water table, we can't just take 20 and times it by 4 and add it together. We have this uplift pressure caused by the water, and the unit weight of 9.81 kilonewtons per meter cubed is going to come into play. So first, here's the by the book way. We're going to go 4 times 20, just like we did with the sand layer, and we get 80 kilonewtons per meter cubed. And then we come down here and we calculate the water, the uplift pressure, 9.81 times 4 equals 39.24. So what we would do for this bottom clay layer here, we would take 80 minus 39.24, and that would equal 40.76. So we could add 72 plus that 40.76, and voila, that gives us the answer of 112.76. And that's close enough. We could round to answer B. Now, here's an even quicker way to do this on the exam, in my opinion, that can save you some time, which is valuable on the FE exam. You need every precious second. Is I would take this unit weight of the clay, subtract that by the unit weight of the water just right off the bat to get you 10.19, and then multiply that by 4. It's slightly faster, it's quicker, and it's cleaner than doing the method of adding the water, adding the clay, especially with a more complicated problem with multiple layers and multiple different layers across water tables. This is a little simpler version, and just compacting that into 40.76, adding that to that 72 we got, and then finding the correct answer there. So that's how to solve an effective stress problem at a depth, a geotechnical problem with a little water table thrown in there. If you have any questions, leave it in a comment down below. Go ahead and pick up my guide, the 5 steps to solving any FE exam problem. I also have a 90-day FE exam study plan that you can get for 100% free in the description down below, just providing a lot of resources for you guys to help pass. If you have any questions or any problems you'd like to see, leave it in a comment down below. Thanks so much for watching. And anyways, I'll see you guys in the next video.